Throwback Thursday, the 15th of April. We'll hear a throwback song after this one. You guys will be able to solve quadratic equations by factoring. Section 7.6, we're going to do half the section today, half the section next class as well, okay? Now, yes. Now, on this, we've been building up to this all chapter, actually. Both chapters 7a and 7b has been building up to this section. This is kind of the final piece of it, so to speak. We take what we've been learning so far, and we put it, and we add one more step on, okay, to actually solve an equation. We've been doing mathematical expressions, but what's the difference between an expression and an equation?
Everything's zero.
What's the difference between an expression and an equation?
Equations you can solve it.
Equations you can solve, and you have an equal sign. Hence the equation starting off with the equa sign, equa kind of wording there, okay? Maddie.
This is a relative, but is that a bird or an eye?
Is that a what?
Bird or an eye?
On the board?
Yes.
It's an eye.
It looks like a bird from like right around here.
All right. All right. For each of the following, find the answer. What is 9 times 0? 0. What is 3a minus 4 when the whole thing's multiplied by 0? 0. What is 8 times 2 minus 3t times 0?
0.
Wait. Would anything times 0 be 0?
Yeah.
Yeah.
Yes.
That's always true, right? Doesn't matter what you take times 0, you're going to get 0 every time. Now let's say I were to take 5 times any number, let's maybe call it x for now, equals 0. What would x have to be?
0.
Why does x have to be 0? Because it equals 0? Because 5 times... Would 5 times any other number get 0? No, just 5 times 0, okay? What if I change it instead of 5? What if it, in x, what if it was... 2097 y?
0.
Y is going to be 0, right? Because something times something equaling 0. At least one of the things has to be 0, right?
Yeah.
Now, could they both be 0? Could it be like 0 times 0? Would that work too?
Yeah.
Yeah. So no matter what, if you have things multiplying and it equals 0, one or both, so at least one of the things has to be 0, right?
Yeah.
That's what this thing called the zero product property tells us. Zero product meaning product multiplication that equals 0. For all numbers a and b, any two variables, any two numbers, if a times b, if two numbers multiplied together equals 0, then either the first one's 0, the second one's 0, or they both are. Is that kind of what we were just talking about a moment ago? Yeah, that's all it's saying.
Alright, can we get the homework now?
Now, anytime you have an equation equal to 0, at least one of the factors are things multiplying together, must equal what?
0.
0.
Awesome.
So here's some important things to remember. The first one is that this only works for multiplication. It does not work for addition, subtraction, or division. So let's say, for example, you were to have 5 plus x equals 0. Do we know x is 0 in this scenario?
No.
No, x is going to be negative 5.
What?
If you have 5 divided by x equals 0, this won't work because x can't be 0 because then it'd be undefined. Excuse me. We couldn't do 5 minus x equals 0 because then would x still be 0?
Yes. No.
No, it has to be positive 5. So it only works for multiplication. And the other thing is the equation must equal 0. It doesn't work if it's equal to something else. So let's say like in the above examples, when I had 2097y equals 0, let's say I changed it to 2097y equals 1. Does y still have to be 0? No. It has to be something else. It has to be something else. Okay? It's going to be 1 over 2097 actually. But
2098, right?
no, it'd be 1 over 2097 because then they would cross reduce. All right.
Yeah.
So, In these examples you see right below in your notes,
Yeah.
x plus 3 is doing what with x minus 5?
Multiplying.
Multiplying. So there are two things multiplying. And what do these things multiplying equal?
0.
0. So we have multiplication that equals 0. So we just learned that at least one of these things has to be
0.
0. Otherwise it doesn't work. So what we do is I say, okay, well, what will make this first parenthesis 0? So instead of guessing and checking and saying, well, maybe this, maybe this, maybe this,
0.
we actually just set it equal to 0. We say, hey, if x plus 3, if that first parenthesis does equal 0, this equation is true. So then we solve this. And we say, okay, well, how do we solve x plus 3 equals 0? How do we get x by itself? Subtract 3. We've done an equation like this a long time ago, right? So x is negative 3. If I were to plug back negative 3 into these, walk through me with that real quick, okay? Negative 3 plus 3. 0. Negative 3 minus 5. Negative 8. Would 0 times negative 8 be 0? Yeah, it works. Now, so it works for that. But it's possible that x minus 5 could be 0 as well. So how would I get x by itself in this one? Add 5. And so x is 5. So walk through this scenario with me. If I plug 5 back in, what's 5 plus 3? 8. What's 5 minus 5?
0.
0. Would 8 times 0 be 0?
Yes.
Yeah, so when x is negative 3, it's true. But it's also true when x is 5, right?
Yeah.
So how many answers do we have? We have 2.
Mr. Boswell.
We have 2 different answers. Yes. Okay, Aiden. If you're back within 5 minutes. Okay. So we end up getting 2 answers. We said, hey, if either of these is 0, it works. So we set them both equal to 0, and we solved them. Questions on that?
No.
So in this next example, do we have a very similar setup?
Yes.
Yeah, we have 2 things that are multiplying to equal 0. So what do we think we might do?
The same thing that we did on the first one.
Okay, which is what?
2a
Plus 5 equals 0. And what would another equation be that we do?
a plus 7
A plus 7
equals 0.
equals 0. These are both possible equations here, right? And we need to solve each of them. We'll solve them separately though, right?
Yep.
Go ahead and try solving these on your own. So on 2a plus 5 equals 0, what's our first step in solving that equation? Subtract 5 to move that over. Very good. 2a is negative 5 equals negative 5. What's our second step in solving that equation? Divided by 2. Now this creates a fraction. Am I okay with fractions? Yeah. Can we reduce this fraction? No. So we leave it. We could make it a mixed number. And some teachers would prefer that. Personally, I'm okay with either. The second equation, before I move on to the second equation, this is saying, in the first equation, a equals negative 5 over 2. If I plug in negative 5 over 2 into both a's, I end up getting 0. Because it makes the first parenthesis 0. How do I solve the second equation? I started shaking my head, but it was right. A is negative 7. So if I plug in negative 7 to both parentheses, which parenthesis does that make 0? A plus 7, the second one. And then the whole thing turns to 0, because you have something times 0. In that case, you'd have 9 times 0. Tobin.
What if you don't have a fraction on it? Is it still correct? Like if it's
You don't have to have fractions.
Oh, okay.
So, Tobin, did our first problem have fractions?
No.
No.
Okay.
What is CD8? Wait, no. CDT. Look for time zone. What is that? Central? The
I don't know what the DT stands for.
District time.
district time?
Maybe.
All right.
I'm just guessing.
3. Wait, what's different on number 3? There's 3 different things. Now wait, did that change it up above earlier when we had 3 different things that equal 0? Multiplied to equal 0? No. So what do we think? How many equations do we think we're going to have this time?
3.
3. 1 for each parenthesis. Okay. Reagan, can you tell me my first equation?
2x minus 7 plus 0.
Very good. Sure. Maddie, do you want to tell me the second equation first, though?
Yeah. X plus 5 equals 0.
Very good. Very good. Hannah, do you want to tell me that last equation?
X minus 8 equals 0.
Very good. All right, go ahead and solve these on your own. If you ever have questions, raise your hand. That first equation, we had 7.
Interesting.
Yes. Good luck. First equation, add 7. 2x is 7. Divided by 2. Does 2 go into 7, guys?
No.
No, so we leave it at 7 over 2 because it doesn't reduce either. Second equation, subtract 5. X is negative 5.
I think you need to come and look at my squares because I didn't practice them and that's pretty close.
Ooh, alright, alright. And then the last one, x is 8. So how many answers did we get this time, guys?
3.
3, okay. And how many parentheses did we start with this time?
3.
Ooh, those are good. Those are fresh. Lainey, what?
No.
No. Alright. Wait, whoa, number 4. What changed?
There's no parentheses.
There's no parentheses. So on the first 3, we had multiplication that equaled 0, right?
Yeah.
On number 4, do we have any multiplication really?
No.
Now, what symbols do we see instead? Subtraction. Number 5, we notice the same thing, addition and subtraction. And 6, subtraction. So, here's what we do. We use factoring. Factoring was the method we used to create multiplication. Hence, factor, multiplying together, factoring, turn it into multiplication. So we use factoring to turn addition and subtraction into multiplication. So we're going to use this here to turn this into multiplication. Yes, Maddie? Not quite, not yet. Yep. Do we look for a GCF on number 4? We look for one. Do we find one? No. So there's 3 terms. What did we do when there was 3 terms? Make an X. Very good, Reagan.
You gave me the long way.
Ooh, actually, no. Can we do the shortcut here?
Yeah.
Yeah, how do we know we can do the shortcut, guys? Because there's a 1 in front of the x squared. That's the best. What goes to the top of this x? Negative 10, because it's a times c. 1 times negative c. 1 times negative 10, excuse me. And what is at the bottom? Negative 3, because that's the b. Remember, the b goes on the bottom. What kind of numbers are going to multiply to a negative? 2 with the same sign or 2 different? 2 different. A negative and a positive. 2 factors of 10, a minus and a plus, those are really going to subtract, that have a difference of 3. 5 and 2. And the 5 is negative. Why does the 5 have to be negative here? Because it's bigger, and the 3 is negative. Now, we can do the shortcut, like I said. So how do I write the shortcut for my parentheses? Just x. Yep. No. X minus 5 and x plus 2. So both parentheses start with the variable x. Not squared, but just x. Then they end with the number and signs from the sides that we found. Negative 5 and positive 2. Now wait, what do we notice that we still have equals 0? So we have to write that in here. We still have it equaling 0. Now, does this look a lot like the problems we just had?
Yeah.
Yes, I want you to finish them from here on this one. I want you to finish this one from here. Looked around, saw some really good things here, guys. x minus 5 equals 0. X plus 2 equals 0. So we are at the point here in the purple and orange, right before I wrote this last two equations, where you have multiplication that equals 0 again. So from there, we set up each factor, each thing's multiplying together, in this case the parentheses, to equal 0. Now we solve these. Add 5 to both sides of the equation for the first one. X is 5. Subtract 2 to both sides of the equation for the second one. X is negative 2. That tells us, blessing was rain down, that's good. That tells us, if I were to take 5 and plug it into both x's in the original equation, it ends up working out to be 0 equals 0. Or if I take negative 2 and plug it into both x's in the equation originally, we get 0 equals 0 as well. So both will work. And we always have a way to check our work, right? That's our way to plug them back in. Has there been like anything we've done this year where you didn't have a way to check your work?
No.
No. So could you get like hundreds on all your tests if you checked your work all the time?
Yeah.
Yeah. Okay. Now, what was different here on number 4 versus the previous ones again is we had subtraction instead of multiplication. Whenever you have anything but multiplication equals 0, you have to turn it into multiplication by factoring. So as we turn on to number 5, do we have multiplication that equals 0?
No.
Is it multiplication? No, it equals 0, but what is it? Addition and subtraction. So what do we do to turn addition and subtraction into multiplication?
X.
We factor. In this case, we make an x. Now, as we do this problem, what goes at the top? Negative 6. And what goes at the bottom? 1. So we need two factors of negative 6. Wait, if they're going to be negative 6, what are the two signs going to be? Negative and a positive. Very good. And it's going to be a 2 and a 3 in that order. Very good. The 3 has to be positive because it's bigger, and it's the same sign as the 1. Now wait, can we do our shortcut this time?
No.
Darn it! We're back to our long way. Reagan, can you help me do the long way?
6x squared minus 2x, 3x minus 1.
Very good. So Reagan says, hey, I rewrite the first term, 6x squared. I rewrite the last term, negative 1. That middle plus x splits into the negative 2x and the positive 3x that I found by making, by doing my factors.
Do we do it that way though?
Yep. And we set that equal to 0. Now, we group the first two together, and we group the last two together. Just like we did before. Do you guys remember doing this?
Yeah.
I hope so. It wasn't that long ago.
I remember.
What is the GCF of 6x squared and 2x? 2x. And what's left, excuse me? 3x minus 1. Is that already what's in the next parenthesis?
Yeah.
Yeah, so what do we take out then? Just a positive 1. Very good. And we're still left with 3x minus 1 equals 0. Now, we notice that 3x minus 1 is the same in each parenthesis. So what do we do with that?
Put that out in front.
Put that out in the front. Very good, Tucker. Oops, excuse me. Getting ahead of myself. And then what makes my other parenthesis? Because we always have 2.
2x plus 1.
2x plus 1. And this still equals 0. Now, are we at that same place we were earlier?
Yes.
Yes. I want you to solve these. You should get 2 fractions, and I'm okay with that. When you have it or have questions, raise your hand. Alright, let's talk about this one up here. So we set up these equations equal to 0. 3x minus 1 equals 0. 2x plus 1 equals 0. Anytime you have multiplication that equals 0, you can do this. So we add the 1 to both sides of the equation to solve the first one. 3x is equal to 1. Divide by 3. X was 1/3, right? Other equation. Subtract 1, subtract 1. 2x is equal to negative 1. Divided by 2. And x is negative 1 over 2. Questions on that? Alrighty. I'm going to kind of section off number 6 there so we can actually see it. Does that help?
Yeah.
Okay. Alright, number 6. Do we have multiplication that equals 0? No, we don't. We only have multiplication. It does equal 0. So how do we turn addition and subtraction, in this case subtraction, into multiplication? We factor. Now what, is there a GCF here? We always look for one. 6 what? 6x. And if I factor out a 6x, what do I have inside my parentheses still? X minus 4. So we look inside the parentheses to check, can we factor any more inside the parentheses? We spent the last few days looking at that. Can we factor any more inside the parentheses? X minus 4. They don't have anything in common. It's two terms and a subtraction, but is x a perfect square? No, nothing times itself is x. So we leave it as is. So now, is 6x multiplying with x minus 4?
Yeah.
So do we have multiplication that equals 0?
Yes.
We actually do. So we're going to set 6x equal to 0. And what else are we going to do? What was that? In a moment. But what's the other equation we're going to do?
X minus 4.
X minus 4 equals 0. So we set both of those that multiply together equal to 0. Is Aaron, you writing this? Thank you, buddy. All right, the first equation, 6 times x. Well, they're multiplying, so what do we do to undo that? Divide. And what's x? 0. Anything divided by 0. Or anything, 0 divided by anything, excuse me. What do we do with the other equation? 4. Once again, we have 2 answers. Now, guys, you might notice a theme of having multiple answers, right? Here's why we always have 2 answers in these problems. When we see the highest exponent is 2, 2 answers. Highest exponent is 2, 2 answers. Highest exponent is 2, 2 answers. Whenever you see the highest exponent, that's going to be how many answers you should get. Questions on that? All right, Tobin.
So the exponent was 6. You have 6 answers.
You darn would.
Oh,
Yep. So number 3, it was already factored for you.
yeah.
But before it was factored, the highest power was 3. Hence why it has 3 answers.
Oh, okay.
Great question.
So if it has 3% for parentheses, it's 3.
Potentially, yeah. Let's look at number 7. This is the last one we'll do today, okay? Sound good?
Yeah.
X squared minus 16 equals 0. Wait. Is there multiplication that equals 0?
No.
No, we're not ready to solve then. We need to create multiplication. How do we turn subtraction or addition into multiplication? Factoring. Factoring is the answer to that.
X minus 4.
Oh, we can make 2 parentheses, huh? What's the first parenthesis going to be?
X minus 4.
Okay, what's the other parenthesis?
X minus 4.
Ooh, not
X
quite.
plus 4.
X plus 4. Mason, what is this? Does this look familiar then?
Yeah.
Looks pretty familiar to Mason. Mason's saying, hey, I've seen this before.
But how did you get 4?
Great question. So Mason's like, I've seen this before. This is a difference subtraction. Is x squared a perfect square?
Yes.
Yeah, what times what is x squared?
X.
X. Is 16 a perfect square?
Yes.
Yeah, what times what?
4.
4. So we make our 2 parentheses. One's x minus 4, one's x plus 4. The square root of the first in both parentheses, minus and plus the square root of the second. Now this is just equal to 0 now, right?
Yeah.
So can we solve these equations like we have been? So we have to set up the equations. Okay? Tobin, you want the first equation?
Yeah.
How do we set it up?
X equals,
Nope.
or no, X minus 4 Equals 0.
Very good, very good. Now I'll pause. Olivia, tell me the second equation.
X plus 4 equals 0.
Very good, very good, very good. Now we solve these equations. Are these equations the hardest ones we've ever solved?
No.
Yes.
No, they're not. Okay? These are way back from last semester, right? Like
Yeah.
early last semester, okay? How do we solve the first one?
Minus 4 on each side.
Not minus.
Plus 4.
Add 4 to both sides.
Yeah.
X is 4. How do we solve 4 in the second one?
Minus
Minus 4.
Minus it. So
And equals
negative 4.
X.
X equals
X
negative
equals
4.
And those are the two answers, right?
Yep.
Question on that at all?
No.
Okay.
None of them.
I want you to do, for now, don't cross any out. 2, 4, 6 through 11.
What?
What
It's so much.
is it?
Stop complaining or else he's going
As well as 13 through 14.
13 through 14?
Yes. So 13 and 14. I mean, it could be worded either way. Tucker.
I confused myself in the first place. And you said we're starting at 2, and I looked up 6, and I was like, wait, what? There's no 2.
So we're doing 2. Yep. Oh, gotcha. You're just saying hindsight.